Okay, we're going to go over two problems here, so make sure you have number 3 and 4 done before you start watching this video. If you've already started, press pause, finish 3 and 4, and come back and watch the video. Number 3 says that Mr. Szabo went downtown this past weekend. The parking cost $7.75 for the first hour and $2.50 for each additional hour. So our function rule that we have to write here is going to have a dependent statement. The parking cost will depend on the number of hours. So cost depends on hours. We can define our variables. C will be our cost. Let's make that look a little better. And H be the number of hours. One thing that we got to keep in mind here as we're working on this problem is that it says that the first hour is $7.75. It's $2.50 for each additional hour. So if we're there for 1 hour, we don't pay this. That's an additional hour on top of that first hour. So we have to keep that in mind as we're writing our function rule. So we are defining our variables. That's done. Writing the function rule to describe how much it costs to park. So we want to know the cost, and it's going to be equal to, well, it's $7.75. And that's my addition, $2.50 for each, which is multiplication, additional hour. We should have 7.75 plus 2.5 H for the number of hours. Part C in this asks, if I paid $20.25, how many hours was I parked in the car? So, and it should say his. That's awkward. So how many hours was I parked? The cost is $20.25. 20.25 is 7.75 plus 2.5 H. That's my algebra problem now. Go ahead and solve that equation. Press pause, solve the equation if you haven't done it. If you're checking it, you should be ready, and the answer is going to pop up momentarily. So when we solve this equation, we wind up with H equals 5. We haven't answered the question though. So I paid $20.25. How many hours was my car parked? If H is 5, remember, this is the number of hours, but it's the number of additional hours. So my car was parked for this first hour as well. So to answer this question accurately, it is not 5 hours. My car was parked for a total of 6 hours. The 5 additional plus the $7.75 for my initial hour. Okay, so that's number 3. If you haven't done number 4, now's your last chance. Hit pause and go ahead and start and finish number 4. So here we go. Number 4 says that Alyssa earns a weekly salary of $250 selling shoes at the Skechers store. In addition to her salary, she earns $5.50 an hour for every extra hour of cleanup she does. We need my dependent and independent variable. So in addition to her salary, she earns this for every extra hour. So again, we have time in here. Time is always going to be independent. It doesn't depend on anything. So the number of hours is going to be my independent variable. The dependent is going to be her weekly salary, because the salary will depend on the number of hours that she works. I go ahead and define my variables. Salary, I'll use an S. S is her weekly salary. And for the number of hours, we can use H again, and we will state that H is the number of hours. We cannot have 100% on a problem if we do not define our variables. So part B, write the function rule. Her salary depends on the number of hours. Her salary is $250. That's no matter what. But if she works some extra hours cleaning up the store, she gets $5.50 an hour. Here's multiplication again. So that's times H. So my function rule, her salary, will be equal to the $250 selling shoes plus any extra hours she works cleaning up the store, $5.50 times the number of hours. Part C says, this week her goal is to make $325. How many extra hours of work does she do? So if she's getting paid hourly for that extra work, that's what we're looking for. We know that her salary, she wants to be $325. So when is that equal to 250 plus 5.5 H? We're solving for H here. If you haven't already done it, go ahead and do that now. Press pause, solve for H. Okay, so my exact answer here would be 13.63 repeating equals H, or the number of hours that she'd have to work is 13.63 repeating hours. Obviously, she can't work for a 0.63 repeating of an hour. So we would want to round this. Now, we'd have to be careful. The problem may or may not say round to the nearest hour. It may just say how many hours, exact number of hours, something along those lines. So we have to keep in mind, if she works 13 hours, she's not going to make this much because it's more than 13. So we might want to answer this question saying 14 hours. 13 hours would not be enough. She would not make $325. She'd make less than that. At 14, she'd make a little bit more than that.